Hello everyone. Today I am going to teach in trigonometry topic inverse trigonometric functions. What is inverse trigonometric functions? Already we have learned in functions topic what is inverse function. Suppose if f is mapping a to b, f inverse maps b to a means it will interchange. Means the domain of f is equals to range of f inverse. Okay, and range of f is equals to domain of f inverse. These are equal. Okay, inverse function is not suppose inverse of trigonometric function is means it doesn't mean that 1 by sin x. It's not reciprocal. Inverse it is like represented by like this, sin inverse x is not equals to 1 by sin x. 1 by sin x means obviously you can say that 1 by sin x is cosecant x, means inverse function is not equals to reciprocal of its function. Okay, now see, as you know that this domain of f is equals to range of f inverse and range of f is equals to domain of f inverse. Okay, so now we'll see the graphs. Okay, let us go for that. Y is equals to sin x and y is equals to sin inverse x. You see these diagrams, sin x is always passing through the origin. Okay, and sin pi by 2 will be 1 and the sin minus pi by 2 is minus. The curve will be like this. Means if you are rotating like this, okay, on x-axis it will be values and y-axis pi by 2 minus pi by 2. It will be, if I am rotating like this, it will, okay, inverse function. And also inverse function will be, when the inverse will be existing already, you are aware of that. If it is 1 function, then we can say that it is inverse existed. How can you say that the given function is 1 function or not? See, f is equals to, so for example, 1 comma a is there, 2 comma b is there. F inverse is equals to a comma 1 and b comma 2. We can, so here there is no first coordinate is not repeating, there is a function. And when you interchanging also, f inverse also function. If f is a 1 function, f inverse also 1 function. Okay, now inverse will be exist only when f is 1 function. Okay, and if the graph is there, how will you know that whether the given graph is 1 function or not? Suppose the curve is like this. If I'm drawing a this is a horizontal test. If I'm drawing a line which is parallel to via x-axis, then if that line intersect the curve at only 1 point, then we can say that that is a 1 function. Okay, now means for this inverse will be existing over here. Okay, inverse function is always symmetrical about y is equals to f of y is equals to x. Means if the graph will be like this, it will come. It is symmetrical about y is equals to x line. Okay, now remember that. Now, if you see this one also, what it is over here, if I am taking like this is f of x is sin x will be like this. Okay, now it is symmetrical about y is equals to x. Okay, means inverse function is symmetrical about y is equals to x, the line. Okay, so inverse function will be inverse of this one. Means, see, whenever you are taking a sine inverse of 1 is there. So generally, when you will, how will you simplify this one? Actually, in sine table, 1, when will you get that? Pi by 2. So this will be pi by 2. Means sin x domains will be minus pi by 2 to pi by 2 and sin x range will be minus 1 to 1. So it will be reverse. For sin inverse x domains will be like minus 1 to 1 and the range will be minus pi by 2 plus pi by 2. That just we have to flip the diagram like this. In the same way, cos x also say here. Cos x is domain is 0 to 5, range will be minus 1 to 1. So domain is equals to range of cos inverse. So it will be range and this will be the domain. Okay, so domain of cos inverse x is minus 1 to 1 and the range will be 0 to pi. Okay, these are the like principal values. These are our principal values. If I'm taking this cos x, cos 0 is 1, cos pi by 2 is 0, cos 180 will be minus 1. Now, if I'm rotating, if I'm flipping the diagram like this, it will be that the cos inverse x will be like this. Okay, now See here. Next, even tan x also, same thing. Tan x domains will be minus pi by 2 to pi by 2. Range will be real numbers. So the domain will be real number. The range of tan of 6 is minus pi by 2 to plus pi by 2. So see here also the tan x, tan 0 is 0, tan 90 is undefined. That you know very well. Tan x curve already I have explained you in the previous class. Okay. Now here it will be not defined. The diagram will come like this. It will be if I'm doing like this. Okay, it will be symmetrical about if I'm doing like this, symmetrical about y is equals to x. Okay, this is how we can define that inverse function. So, for example, in the quadrant, suppose see, uh, okay, tan inverse. Suppose I am taking 1 by root 3. For example, assume when will you get tan inverse? Tan table 1 by root 3, tan of 30 degrees. So 30 degrees will be, it's nothing but pi by 6. Simply we can do. For example, if it is negative is there, like tan inverse of negative is there, then how will you simplify this? Okay, now see here that there is an easy method for that. See, this is negative angles means like a clockwise direction. This you know very well. So this will be the minus theta. Okay, and this will be minus pi plus theta, and this will be minus pi minus theta. This will be minus 2 pi plus theta. Okay, obviously this is 0, this is 0 and minus 90, and this will be minus 180 and minus 270, and if I'm going, this is minus 360. This is a clockwise direction. Now, whenever you are taking, so tan is negative in which quadrant? First of all, you check it out that. Okay, and before doing this, there is a formula for that. Sine inverse of minus theta and cos inverse of minus theta, tan inverse of minus theta. Okay, so for sine inverse of minus sine theta, tan also minus tan inverse theta, but cos inverse of minus theta will be pi minus cos inverse theta. Okay, so these formulas we can apply and we can simplify that. So tan inverse of minus theta is minus tan inverse, okay, 1 by root 3. Now 1 by root 3, when will you get? Pi by 6. So minus pi by 6. For example, if I am taking cos inverse of minus 1 by 2. Cos inverse of minus 1 by 2 formula is what it is over here. And also this will be defined only in its domain only. In its domain means my here minus 1 to 1, here also minus 1 to 1, here real number, any real number. Okay, now it is defined only in its domain. Okay, and it will be 5 minus cos inverse theta 1 by 2. Theta is nothing but what actually what it is over here, value will be 1 by 2. So pi cos inverse 1 by 2. 1 by 2, when will you get in cos table? Cos 60 will be 1 by 2, means pi by 3. Okay, now pi minus pi by 3, 2 pi by 3. So this is how we have to simplify the values. Okay, so now look at the problems. Now see here. Okay, oh, we have done these problems just now. Tan inverse of minus 1 by 3, cos inverse of minus 1 by 2. Okay, this is done. This will be, what did I get over here? Minus pi by 6, minus pi by 6, and this will be, what it is over here? 2 pi by 3. 2 pi by 3. Now, second question. The function f of x 3 sin x minus 4 defined in its domain. This domain is already as given. Find the range. Okay, and sin x is always lie between what it is minus pi by 2 to plus pi by 2. So then if it is minus pi by 2 to plus pi by 2, minus pi by 2 to plus pi by 2, then the range will be minus 1 to 1 sin x. Okay, na? Minus 1 to 1. So what is the function over here? 3 sin x minus 4 is there. So multiply 3. 3 sin x minus is 3. And here minus 4 is there. So minus 4, you should add all the sides, minus 4. So minus 4, 3 minus 4. What is that over here? Minus 7 is less than or this is f of x. Okay, this is less than or equals to minus 1. So the range will be minus, the range is equals to minus 7 to minus 1. Closed interval means it is included that. Okay, now F inverse x we have to find. F inverse x, how will we find? Same like what we have done in the previous classes function, same like that only. See, let us assume that f of x is equals to y, you assume x is equals to f inverse y. Okay, na? So, therefore, f of x, what it is already? 3 sine x minus 4 is equals to y. Okay, 3 sine x is equals to y plus 4. Now, sin x is equals to y plus 4 by 3. So, x is equals to sin inverse y plus 4 by 3. So, now change the x is equals to what it is over here. X is equals to f inverse y. Write on that. F inverse y is equals to sin inverse y plus 4 by 3. Now change the variables. I want f inverse x. It will be sin inverse x plus 4 by 3. This is how we have to simplify the problem for finding the f inverse x. Okay. Next. See that this question here also has given that f of x is equals to 5 minus 2 sin x is given, and its domain is given pi by 2 to p. P value we don't know. We need to find that. The largest value of p we need to find, which has f inverse. Means which has f inverse, they said. Okay, now, and also we are, after finding the value, we have to find the f inverse x and state its domain. Okay, that's fine. First of all, you say here, sin x is sin x is lie between minus 1 to 1. Minus 1 to 1. Okay. Now, so here 2 is there over it. 2 you multiply. 2 sin x is less than or equals to 2. Okay. Now, so here minus is there. So multiply minus, less than will become greater than minus 2. Write down in proper order. Minus 2 less than or equals to minus 2 sin x is less than or equals to plus 2. Okay. Now, the thing is, next is 5 is there. You add 5. 5 minus 2 is less than or equals to 5 minus 2 sin x is less than or equals to 5 plus 2. Okay. Means it is lie between f of x, lie between what it is for it, 3 to 7. Now, so the maximum value is 7 and minimum value is 3. So now you draw this in the graph. Okay, so 0, 1, 2, 3, 4, 5, 6, 7. Maximum is 7 and minimum is 3. Okay, this is not required. Okay, 0, 5 by 2 you take, 5 you take, 3 pi by 2 you take, and 2 pi. Just I'm taking some values over here. Okay, now what I am doing over here, sine 0 is 0. Means if I put over here f of x, what it is over here, sine 0, 0. 5 minus 0 is, just you write down here, x values, y values, 0, 90, 180, 270, and 360. If I am substituting over sine 0, 0. 5 minus 0 is 5. Okay, 0. And sine pi by 2 is 1. 5 minus 2 is 3. Sine pi is 0. This is 5. And sine 3 pi by 2 is minus 1. So it will be 7. Sine 2 pi is 0. Means it is 5. So you draw this diagram. 0 is 5. It will be over here. Pi by 2 will be 3. It will be over here. Pi will be 5. It will be over here. And 3 pi by 2 is 7. It will be over here. 2 pi means 5. Okay, just the diagram. We draw this diagram. Okay, now see here. I want the limit will be what is minus 5 by 2. Just you draw one imaginary line or just dotted line from here to you should take. Okay, and it is we have to find the largest value of p. It has inverse. Just now I told you that if it has inverse means if I'm taking any curve, if I'm drawing a line which is parallel to x-axis, that should intersect only one point. So if I'm drawing a line from here, horizontal line, if I'm drawing a line, it is intersecting. Okay, here intersecting this point and this point. Means we have, if I'm considering till here, if I'm considering till here, So this horizontal test is satisfying only one point. It is going to intersect on one point. So the maximum value is what it is over here. It will be 3 pi by 2. Okay now. So the largest value of P is what is that? 3 pi by 2. Okay, this is how we have to simplify. If we are going for minus pi, as a place pi by 2, 2 pi means it is going for two times intersecting two points is going to intersect. So it is not a inverse function. If I am considering up to certain interval, you should consider. So only one point. So till here you should consider. So it is 3 pi by 2. At 3 pi by 2, comma 7. So the maximum, the p value will be 3 pi by 2. This is how you have to simplify. I hope you have understood my explanation clearly. Thank you.